Okay, so on this question, this is a question that is gonna seem a little strange to you. Let me show you what I'm talking about. Basically, right here, they're telling me, notice that they've put G into F. But then on part B, they're putting F into G, right? So what that means is they want me to work that out. They want me to take all of G and put it inside F. So I take all of G and I plug it into X's insert slot right there, into the into the X spot, right? That's where you plug into a function. So I'm putting G, all of G into the F. So what do you get? 8 times X plus 9 over 8 minus 9. Is that good so far? See how I just put all of G into the X slot? Let me mention something. Here's a common mistake students have made over the years. They've asked me about. It's a good question. They'll go like this. They'll go, okay, I get it, Ms. Tran, you got to plug it in. So I'll go 8X and then I'll plug it in. No, the X isn't there anymore. Whatever you plug in takes the place of the X, doesn't it? Because the X is just a slot. It's just the holes in the toaster. That making sense? It's like that is correct. This right here is where the X used to be. But the plug-in took the place of the X, right? Because the X was just holding a spot. It's what we call a dummy variable. It's not anything important. It's just holding a spot. So when you plug in, it's not there anymore. The plug-in took its place, right? Anyway, so how do we work this out now? Well, this 8, what do you do when a whole number like 8 is right next to a fraction, is interacting with a fraction? Well, you put it over 1 to make it look like a fraction. It doesn't change anything, makes it easier. And then what can we do? When we have 2 fractions multiplied, we can cross cancel. When we have the same thing, top and bottom, we can diagonally cross cancel. Okay, so what does that leave us? That leaves us X plus 9, and then there's still the minus 9 at the back. And what is that? What is X plus 9 minus 9? Well, that's just X. So the answer is just X. Did you track with that? See that? These 8's canceled out, so we just had X plus 9 minus 9. And then 9 minus 9 is 0, as you know quite well. So it's just X. Okay, how about the next part? Let's try the next part. So now we're going to go the other way. And I'm going to put F inside of G. So I'm going to take all of F and I'm going to plug it in right there into G. Does that make sense? So all of F is going into G. So all of F is 8X minus 9. That's plugging in right there. And then there's the rest of G, plus 9 over 8. Is that good so far? And then on the top, these guys cancel out, don't they? So we just get 8X on the top and 8 on the bottom. The minus 9 plus 9 is just 0. And then those guys cancel out. And guess what the answer is? It's just X again. Did you see that? That making sense? So again, what did I do? I took all of F and I plugged it in right there to G, right? F is inside of G. The 9 minus 9 is 0. The 8's cancel, is just X. Okay, then down here they say, okay, this is called, what's the significance? You tell me. What if let me show you what this means. I know you can see all this and go, what just happened? Why are they both X? And there'll be X for you as well. Both answers are just X for these. So really, I could have just told you that in the beginning. You could just type in X and X. It's going to be X. But I wanted to show you why and how it happens. And now, what does it mean? Who cares? What's significant about that? Well, think about it this way. What if I took bread and I put it in some kind of machine, some kind of function, F, right? And it came out as toast or whatever, and I put it into some other kind of function. And then when it came out again, it was back to the way it started. Started out bread, became toast in between, put it into some other function, and it turned it back into bread. In other words, it ended up the way it started, turned it back to the same way it started. Then what is this right here? This would have to be the inverse function, right? Because it just undid whatever the first function did. That makes sense, doesn't it? So my point is, if you take something like bread or frozen waffles or whatever, you put it into a toaster, then you put it into some other machine and it goes back the way it started, well, then that second machine is the inverse of the first because it undid whatever the first one did so that the final thing came out the way it started. Well, that's what just happened here. We put in X, it went into G, then it went into F, and it came back the way it started. It's just X again. Same thing here, X, F, G, back to X. So what does that mean? These things are inverse. That's just how we prove in mathematics that two functions are inverse functions of each other. If you plug one into the other, if it just comes out to be X, that means they're inverse functions of each other. They're the opposites of each other. They're undoing each other. They're doing the opposite of each other. And so there we go.